The last set of slides in this series are going to address how you liberate fat from adipose tissue and what is the fate of that fat once it's been liberated from storage in adipose. So the problem is, how is energy stored in adipose liberated and transported to other tissues requiring the fatty acids for beta oxidation? The lipolysis of fatty acids within adipose tissues is catalyzed by hormone-sensitive lipase. Hormone-sensitive lipase is activated by increases in concentrations of catecholamines as well as hormones such as glucagon. Hormone-sensitive lipase activity is inhibited by increased concentrations of insulin, and the non-esterified fatty acids, which are released following the hydrolysis within the adipocyte, require soluble protein carriers such as serum albumin to transport these fatty acids to other tissues. Here, in a fasted state, you can see that the adipocytes have now hydrolyzed their triglyceride and have released NEFA into circulation. These have been transported to the liver via soluble protein carriers. Once taken up by the liver, these fatty acids can be packaged into triglycerides and combined with ApoB100 into VLDL particles, which are then released into circulation. These VLDL particles are then free to migrate to the tissues which are requiring lipid. They're acted upon by lipoprotein lipase, and the result is a delipidated or triglyceride-poor lipoprotein and the conversion to LDL. And then this LDL particle takes part in the remainder of the endogenous lipid transport pathway. So ultimately, if you look at this from the perspective of the adipocyte, you have triglyceride constantly entering the adipocyte in the fed state via triglyceride-rich lipoproteins, and these can be either chylomicrons or VLDL particles, depending on what the state of energy intake is. Lipoprotein lipase breaks down these triglycerides, allows the NEFAs to be taken up by the receptors and the fatty acid transporters on the adipocyte. These fatty acids are then restored as triglyceride inside the cell, and until needed, they will remain here within the adipocyte. Catecholamine levels increase, and then we see a direct stimulation of hormone-sensitive lipase, breaking down the triglyceride, producing fatty acids, which are then released into circulation and are able to travel both to the muscle and to the liver to be oxidized. Processes which inhibit this from occurring are buildup of products of beta oxidation, such as beta hydroxybutyrate, as well as insulin, which has anabolic effects, thereby promoting adipocytes to store energy as opposed to liberating it. So generally, this is how non-esterified fatty acid transport from adipocytes to tissues requiring lipid for energy needs works in conjunction with the endogenous and exogenous pathways. Here we have outlined the exogenous pathway of dietary lipid entering. The bulk of this dietary lipid will enter the adipocytes for triglyceride storage, and at this particular time there will be very limited release, if not no release, of NEFA from the adipocyte because of the high levels of insulin. Some of this dietary fat will be taken up by muscle for its energy needs, and some will be taken up by the liver. The liver, through its endogenous process, has the ability then to release lipid to the muscle as well as to the adipocyte for storage, and depending on what the fed state of the individual is, whether or not they're in a completely fed state, where they will then store triglyceride in the adipose, or if they're in a fasted state where they're actually liberating NEFA and it's being released and repackaged to supply the muscles with lipid. This depends on the balance of hormones related to fed and fasted states. So this is how NEFAs play into the entire set of pathways related to lipid transport. In that, in the fasted state, NEFAs are liberated from the adipose tissue, and they can be transported either directly to the muscle via the soluble protein carriers in blood, or they will travel to the liver, where they'll be repackaged as VLDL and then take part in the endogenous lipid transport pathway, again reaching the muscle or other tissues requiring the fat for energy needs. So this summarizes non-esterified fatty acids and their role in the lipid transport pathways of the body. So generally, just to summarize, in the fed state, insulin concentrations are going to be at their peak. They will inhibit hormone-sensitive lipase. Therefore, the levels of blood NEFA will decrease while insulin concentrations are high. Lipoprotein lipase activity will be increased, and this will promote the adipose tissue uptake of fat. In the fasted state, however, insulin concentrations will be at their lowest. Lipogenesis will also be decreased, and glucagon and catecholamine levels will be higher, promoting the lipolysis of triglyceride in the adipose tissue and the release of nephas into the blood. Muscle cells will then preferentially oxidize fat as their primary source of fuel until they are back into a fed state. So this summarizes how non-esterified fatty acids are released from adipose tissue and how this process integrates with the endogenous lipid transport pathway.